Good morning students, this is Amuda from chemistry department. Today we are going to discuss about determination of point group of the molecule by using flowchart. So let us see the flowchart. Okay, this is the flowchart to determine the point group of the molecule. So first we take the molecule and consider whether the molecule is linear or not. If the molecule is linear, this condition is satisfied means yes. Then we consider the molecule have inversion, center of symmetry or not. If the molecule is linear and it also have the center of symmetry, that is inversion center I, means the point group of the molecule is D infinity H. If the molecule is linear and it does not have any inversion center or center of symmetry, means the point group of the molecule is C infinity V. Next one, if the molecule does not linear, means then we go to the second step. If the molecule have two or more CN axes of order greater than 2, the molecule satisfy this condition and it also have the center of symmetry, means then we go to the next step. The molecule have C5 axis. So the molecule have two or more CN axes, then center of inversion, then C5 axis of symmetry, means the point group of the molecule is IH, that is icosahedral. Then the molecule does not have such an axis, so C5 axis is absent, means the point group of the molecule is octahedral. The molecule have two or more CN axis of n order greater than 2 and does not have inversion center, means the point group of the molecule is tetrahedral. Then the next step, the molecule does not contains two or more CN axis of n order greater than 2, means then we next go to the CN axis. If the molecule have CN axis, the molecule satisfy this condition yes, means next the molecule have n C2 axis perpendicular to CN axis. If it is yes, then we see the molecule have sigma h, that is horizontal plane. So the molecule have nC2 axis perpendicular to CN axis and also have horizontal plane, means the point group of the molecule is DNH. The molecule satisfy nC2 perpendicular to CN axis, but it does not have horizontal plane, means then we see whether the molecule have n number of dihedral plane. If it is yes, the point group of the molecule is DND, otherwise DN, that is the molecule have no plane, means DN. Then the next step is the molecule have no such a point, that is no nC2 axis perpendicular to CN axis, means then we see whether the molecule have horizontal plane. Yes, if the molecule have horizontal plane, means the point group of the molecule is CNH. If such an axis is lacking, means then we go to the vertical plane. If the molecule have n number of vertical plane, means the point group of the molecule is CNV. If such an plane is lacking, means then we go to the improper axis of rotation, that is S2N. If the molecule have S2N, means the point group of the molecule also S2N. Otherwise, the point group of the molecule is CN. If the molecule does not have any CN axis, means then we go to the horizontal plane. If the molecule have only horizontal plane, means the point group of the molecule is CS. the molecule does not have any plane means then we consider inversion or center of symmetry. If the molecule have only inversion or center of symmetry means the point group of the molecule is Ci. Then the last one, the molecule does not have any symmetry element except identity. So identity is the default symmetry element. So all the molecules have symmetry element identity. So the molecule have only identity element means the point group of the molecule is C1. So let us discuss some examples. First one, carbon dioxide and acetylene. So carbon dioxide molecule is linear. So both carbon dioxide and acetylene molecule have linear structure. These two molecules have inversion center also. Okay, so if the molecule is linear and also have inversion center means the point group of the molecule is D infinity H. So there are so many symmetry elements present in this molecule, but these two elements can design the point group of the molecule, that is linear and inversion center. So these two molecules have both linear and both molecules have inversion center. So the point group of this molecule is D infinity H. Then the next example is HCl. So HCl is linear molecule, but it does not have any inversion center or center of symmetry. So we already discussed in the flowchart, if the molecule is linear in shape but does not have any inversion center means the point group of the molecule is C infinity V. Then the next example is platinum tetrachloride and benzene. So consider these molecules. These two molecules are not linear. So the molecule is not linear means we can go to the next step. That is, if the molecule have two or more CN axes of order greater than 2. That condition also not satisfied. But these two molecules have CN axis. So platinum tetrachloride and benzene, both the molecules have CN axis. And these two molecules also satisfy the condition NC2 perpendicular to CN axis. So in platinum tetrachloride, C4 axis is the principal axis, and in the benzene molecule, C6 axis is the principal axis. So these two molecules also have NC2 perpendicular to principal axis. So the point group of the molecule is DNH. In specific, platinum tetrachloride have principal axis C4. So the point group of platinum tetrachloride is D4H. And benzene have the principal axis C6. So the point group of the benzene molecule is D6H. Okay. The next fourth example is water and ammonia molecule. So these two molecules are non-linear. We know well what is bent shape, and ammonia molecule is pyramidal in shape. So both the molecules are non-linear molecule. So the next step is we can see these two molecules have two or more CN axes of order n greater than 2. But this condition is absent. So the water have only C2 axis and ammonia have only C3 axis. So this condition is not satisfied. But these two molecules have CN axis. But these two molecules does not have NC2 axis perpendicular to CN axis. So these molecules have only CN axis. Then let us see these two molecules have horizontal plane or not. These molecules have only vertical plane. Both water molecule and ammonia molecule only have vertical plane of symmetry. So there are vertical plane of symmetry. So the point group of the molecule is CNV. So in specific, water molecule have C2 axis. So the point group of the water molecule is C2V. And ammonia molecule is C3 axis. So the point group of the ammonia molecule is C3V. And the fifth example is anisole and phenol. These molecules are not linear in shape and these two molecules does not have any CN axis. So these two molecules only have identity and horizontal plane. So these two symmetry elements are only present in these molecules. So if only horizontal plane is present in the molecule means the point group of the molecule is CS. Okay, these two molecules both are having only horizontal plane. So identity is the default element. So the point group of the molecule is CS. Then last example, bromochlorofluoromethane. So we know that methane is CH4. So in this molecule, 3 hydrogen atoms are replaced by bromine, chlorine and fluorine. So this molecule is not linear in shape and this molecule does not have any symmetry element except identity. So this molecule only have identity element. If the molecule have only identity element means then the point group of the molecule is C1. Okay, so these are some examples of molecules. So by using this flowchart, we can find the point group of the molecule. Okay, thank you.